Hello everyone, in this video we're going to review Unit 1, Topic 1.1 to 1.16 of AP Calculus AB and BC. Part 1, do not use a calculator for problems 1 to 37. Alright. Question 1, f of -5 is right here. F of -5 is could be right here. The answer should be 6. Question 2, f of 2 is right here. The answer should be 1, right? Question 3, f of 4 is right here. F of 4 should be this one, right? So it could be -3. Be careful. This one is the limit because you see the hole right here, right? This is the dot. So keep that in mind. Question 4, limit of LS when s approaches -7. So -7 is right here. So the answer should be right here. It could be 2. Now question 5, limit of the function f of s when s approaches -5. -5 right here. It's still 6, right? Question 6, limit of the function f of s when s approaches 2. S approaches 2, it should be right here. The answer should be 3. Now question 7, limit of the function f of s when s approaches 4. So we look at 4 is right here. We see that limit of f of s when s approaches 4 minus is 2. 4 plus is -3. So it's not going to be the same thing. Then the limit of f of s when s approaches 4 does not exist. Question 8, limit of the function f of s when s approaches 0. So 0 is right here. Limit of the function f of s when s approaches 0 plus is positive infinity. When s approaches 0 minus, it can be negative infinity. They are different. So the limit does not exist. Now question 9, limit of f of s when s approaches 0 minus is negative infinity. Or you can say does not exist. Right? It's going to be right here. Limit f of s when s approaches 0 plus, it could be positive infinity. Or you can say does not exist. Right? It's right here. Question 11, limit of f of s when s approaches 4 plus. 4 right here, 4 plus, it could be -3, right? Limit of the function f of s when s approaches 4 minus. 4 minus is right here. It could be 2. Question 13, limit of f of s when s approaches negative infinity. So when s approaches negative infinity, this guy keeps getting closer to the x-axis, which is 0 right here, right? It's above the x-axis, so it could be 0 plus. Question 14, limit of f of s when s approaches positive infinity, it could be right here, right? The function is always below the x-axis. It's getting closer to the x-axis, right? So it should be 0 minus. Let's move on to question 15. Use the definition of a continuous function at a number to answer the following. Now, a function f is continuous at a number a if f of a is defined. Limit of the function f of s when s approaches a exists. What does it mean? It means limit of the function f of s when s approaches a minus equals limit of the function f of s when s approaches a plus. Number 3, limit of the function f of s when s approaches a equals f of a. Right. Now, question A. The function f is not continuous as s equals -7. We look at -7. It's going to be right here. Because f of -7 is undefined, right? We have the limit right here is it. But f of -7 is undefined. So number 1 right here does not satisfy, right? F of -7 is undefined. Question B, the function f is not continuous as s equals 2. S equals 2 is going to be right here. The limit is it, right? F of 2 defined, right? But they're not going to be the same, right? So number 3 right here does not satisfy, right? So you need to say f of 2 is not equal to limit of the function f of s when s approaches 2, right? Question C, the function f is not continuous at s equal 4. 4 is right here. Again, the limit of the function f(s) when s approaches 4 does not exist. So these guys violate the number 2 right here, right? Now question 16. Limit of the function -s² plus 4s when s approaches 2. Substitute 2 for s. So it's going to be -2 squared plus 8. So it's going to be 4, right? Question 17. Limit of square root of s minus 3 over s minus 9 when s approaches 9 minus, right? So we just substitute 9 for s. We see that the top is 0, the bottom is 0, right? So this one is the indeterminate form, right? We just factor the numerator and denominator to simplify first, right? So it could be limit when s approaches 9 minus square root of s minus 3 over square root of s minus 3 times square root of s plus 3, right? We're going to use a different square formula, right? A squared minus b squared equals a minus b times a plus b, right? So this guy cancel out, so it could be limit 1 over square root of s plus 3 when s approaches 9 minus, right? So the answer is 1 over 6 minus y, because s approaches 9 minus, which is the number on the left of 9, right? So it should be less than 9, right? So if this guy less than 9, square root of a number less than 9 is going to be less than 3. 3 plus 3 is going to be 6, so it should be 6 minus, right? So be careful. Now question 18. Limit of the function s over tangent s when s approaches 0. We're going to substitute 0 for s. We have 0 over 0. So this one is the indeterminate form, right? So we need to manipulate this one a little bit. So it's going to be limit when s approaches 0, right? Of s over tangent s is going to be sine s over cosine s, right? So then it's going to be limit when s approaches 0 of s over sine s times cosine s, right? Then it's going to be limit of s over sine s when s approaches 0 times limit of cosine s when s approaches 0, right? We know that this guy is 1 by the formula, right? So the answer is 1 times limit of cosine x when x approaches 0 is going to be 1. So the answer should be 1, right? Now question 19, limit of the function x over x plus 2 when x approaches negative 2 plus. Substitute negative 2 plus for x, so it's going to be negative 2 plus over negative 2 plus 2, right? So the top should be negative 2 plus, the bottom should be 0 plus, right? And the answer should be negative infinity of does not exist. Now question 20, we do exactly the same thing, right? So it's going to be 1 plus 1 over 0 minus, right? And then it's going to be 1 plus negative infinity, right? So it could be negative infinity, right? And this one does not exist. Question 21. Substitute 1 for s, so it could be sine of pi times 1, right? So it could be sine of pi, and it could be 0. Number 22. We're going to use the relative growth rate. When s approaches infinity, this guy right here grows faster than this guy, so we just ignore this guy. This guy right here grows faster than this guy, so we just ignore this guy, right? So it turns out to be limit when s approaches infinity of negative 6s to the 5th over s, right? So it's going to be limit when s approaches infinity of negative 6s to the 4th, right? And it's going to be negative infinity, right? This one does not exist. Question 23. We do exactly the same thing, right? So when t approaches negative infinity, this guy grows faster than this guy, right? So we just ignore this guy. This guy grows faster than this guy, right? We just ignore this. So it's going to be limit when t approaches negative infinity of negative t cubed over 7t cubed, right? Now t cubed and t cubed right here cancel out, the answer is negative 1 over 7, right? Question 24. We use the relative growth rate, right? So this guy grows faster than this guy, we just ignore this. These two guys right here grows faster than this guy, we just ignore this, right? So it could be limit when s approaches negative infinity of s over s squared plus 2s, right? Then we just factor s out and we simplify, right? So it could be limit of 1 over s plus 2 when s approaches negative infinity, right? So it's going to be 1 over negative infinity. It's going to be 0 minus, right? Question 25. Remember, we have absolute value of s equals s if s greater than or equal to 0, negative s if s less than 0. Now when y approaches negative infinity, this guy grows faster than this guy, so we just ignore this. This guy grows faster than this guy, we just ignore this, right? So it can be limit when y approaches negative infinity of negative y over square root of 6y squared, right? Now this guy turns out to be limit when y approaches negative infinity of negative y. We check square root of y squared, it turns out to be absolute value of y, right? Times square root of 6 right here. Now we use the formula right here. When y approaches negative infinity, which means y is less than 0, right? So it turns out to be negative y. It could be this case right here, right? So this guy turns out to be limit when y approaches negative infinitive of negative y over negative y square root of 6. Cancel out this guy, so the answer is 1 over square root of 6, right? Now question 26. Limit of the function f(s) when s approaches 2. When f(s) equals this guy and this guy, right? So we need to find limit from the left and limit from the right, right? So limit of the function f of s when s approaches 2 minus is going to be this guy right here, right? Because s less than 2, which means 2 minus, right? So it's going to be limit of s squared minus 3s plus 6 when s approaches 2 minus, right? So we just simplify this one. Substitute 2 for s, the answer is 4, right? Now, limit of the function f of s when s approaches 2 plus, right? We're going to use the bottom one right here, right? So it could be limit of negative s squared plus 3s plus 2 when s approaches 2 plus, it's going to be 4, right? So, limit from the left equals limit from the right, right? Look. So then, limit of the function f of s when s approaches 2 equals 4, right? Now question 27. If a not equal to 0, then the limit of the function s squared minus a squared over s to the 4 minus a to the 4 is what, right? So we need to substitute negative a over here to see what happens, right? The top is 0, right? The bottom still 0. This one is indeterminate form, right? So we need to simplify this one first, right? We need to use different square formula, right, to simplify this one. So we have limit when s approaches negative a. The top I just rewrite s squared minus a squared. The bottom right here I use different of two square formulas, right? So it could be s squared minus a squared times s squared plus a squared, right? So then this guy cancel out. So it could be limit of the function 1 over s squared plus a squared when s approaches negative a, right? So this guy turns out to be 1 over a squared plus a squared. It's going to be 1 over 2a squared, right? Now question 28. Find number c such that f of s is continuous on the entire real line. In order to do this one, we need to use the definition of continuity, right? It's going to be right here, right? So we need to find limit of the function f of s when s approaches 4 minus, right? It's going to be this one right here, right? So it should be 4 square equals 16. Limit of the function f of s when s approaches 4 plus it's going to be this guy right here, right? So c over 4, right? Now, f of 4 is this one right here, right? 16. So the function f of s is continuous. We need limit of the function f of s when s approaches 4 equals f of 4, right? Now, limit of the function f of s when s approaches 4 right here must exist, which means this guy right here and this guy right here must be the same, right? And you see that this guy already is 16 equal this one, so we don't need this one anymore, right? So we just need the limit of the function f of s exists when s approaches 4, right? So we have 16 equals c over 4, right? And then c equals 64. Now question 29. Find the s value, if any, at which the function f is discontinuous, labeled as removable or non-removable. Alright, so basically we need to simplify this one, right? Factor the top is going to be 2 times s plus 3. The bottom should be 2. When you factor 2 out, it's going to be s squared minus 9. This guy actually different of 2 squared, right? So it could be s minus 3 times s plus 3, right? Now, this guy cancel out, right? 2 and 2 cancel out. So the answer is 1 over s minus 3, right? So now we need to answer this one labeled as removable. When you remove s plus 3, this one is called removable discontinuity, right? So you must say removable discontinuity at s equals negative 3, right? Let this one equals 0, solve for s. So s equals negative 3, right? And non-removable discontinuity is the remaining one on the bottom right here. This one actually the vertical asymptote, right? And let this one equal 0, s equals 3, right? Now let's move on to question 30. Determine all the vertical asymptotes of the function fs, right? So we just factor this one and simplify s plus 2 over different of 2 square formula. It's going to be s plus 2 times s minus 2. So this guy cancel out. It could be 1 over s minus 2. So the vertical asymptote is s equals 2, right? We just let the bottom equals 0, so s equals 2. Now, how do we show work if the question wants you to show your work? So you need to say limit of the function fs, we see this one right here, 1 over s minus 2. When s approaches 2 minus, it's going to be 1 over 0 minus, it's going to be negative infinity, right? Similarly, limit of the function 1 over s minus 2, when s approaches 2 plus, it's going to be 1 over 0 plus, it's going to be positive infinity, right? Then the vertical asymptote is s equals 2. Now let's move on to question 31. True or false? If the function f is undefined at s equals c, then the limit of the function fs as s approaches c does not exist. This one false. Why? Because you could have the function like this. Right? So the limit right here is it. Now question 32. True or false? If the limit of the function fs when s approaches c equals L, then f of c equals L. This guy also false. Look at the graph right here. Suppose you have the graph like this. Alright, and the function is defined right here, right? So this is f of c, right, equals L right here. And this guy different, right? So it's not the same. Now question 33. The graph of the function f is shown to the right. Which of the following statements is false? Answer choice A. S equal A is in the domain of f. Yes, because the function is defined, right? Question B. Limit of the function fs when s approaches a plus is equal to the limit of the function fs when s approaches a minus. Yes, the limit right here is it. Question C. Limit of the function fs exists when s approaches a. Yes, because B is right, then C should be right, right? Answer choice D. Limit of the function fs when s approaches a is not equal to fa. Yes, that's correct, right? This is limit of the function fs when s approaches a, right? and this one right here is f of a, right? They are different. Now, answer choice E. The function f is continuous as s equals a. It's not continuous, right? Because limit of the function f(s) when s approaches a is not equal to f of a by definition of continuity. The function f is not continuous as s equals a. So the answer is E. Now let's move on to question 34. We need to find the limit of this guy, right? So we need to expand this one and simplify, right? So we have limit when delta s approaches 0 of use complete square formula to expand this one. So it could be s squared plus 2s delta s plus delta s squared minus 2s minus 2 delta s plus 1 minus s squared distribute -1, right? Plus 2s minus 1 over delta s, right? So it could be limit when delta s approaches 0. Now we're going to simplify this guy, right? So we have s squared and negative s squared gone. Negative 2s and 2s. So we have 2s delta s left right here, right? Plus delta s squared minus this guy right here, 2 delta s, right? 1 and -1 gone over delta s, right? Now we're going to factor delta s on the top out, right? So we have limit when delta s approaches 0 of, when we factor this one and we simplify with the delta s on the bottom, right? So it's going to be 2s plus delta s minus 2. When delta s approaches 0, this guy equals 2s minus 2, right? And this guy actually the derivative of the function f of s when f of s equals s squared minus 2s plus 1 right here, right? Now let's move on to question 35. On the graph, draw a function that has the following properties. A step or a jump discontinuity at s equals 5. So this is 1, 2, 3, 4, 5. Alright, so s equals 5 is going to be right here, right? Now f of 5 equals 6, right? So I have 2, 4, 6, right? So this one should be a dot because the function is defined as s equals 5, right? So I have something like this. Now, because this guy is the step or the jump discontinuity, right? So right here I must have a hole, right? So it could be something like this, right? Now let's move on to question 36. Create a function such that the limit of the function f(s) when s approaches 5 does not exist. So what does it tell us? It tells us the limit of the function f of s when s approaches 5 minus is not the same thing as the limit of the function f of s when s approaches 5 plus, right? Because it is approaching positive infinity from both the left and the right. So we just get the example of the function right here, right? So we locate 5. So suppose I have 5 right here. Limit of the function f(s) when s approaches 5 minus different from limit of the function f(s) when s approaches 5 plus. And they both approaches positive infinity, right? So right here I just draw the vertical asymptote, right? So it could be something like this, right? Now question 37. Find the function f(s) such that f(s) has a hole at s equals 7 and a vertical asymptote s s for -4. Now we're going to convert this one into the factors, right? So we just add 4 both sides. It turns out to be s plus 4 equals 0, right? This guy turns out to be s minus 7 equals 0, right? Now, since the function has a whole, which means there is a common factor on the numerator and denominator, right? So it can be f of s equals s minus 7 over s minus 7 right here, right? Now, since the function has a vertical asymptote as equal -4, so we have a factor right here, should be on the bottom, right? Now, on the top right here, you could leave it like this, or you can put any number right here, right? So, for example, I put 6, 7, right? Now, let's move on to the second section. Calculators is allowed, right? So, question number 1. Approximate the limit numerically by completing the table, right? Now, when s approaches 1.9, we're going to print up the calculator at calculator. Now, we're going to hit the fraction right here. So we put 1.9 squared over 1.9 minus 2, right? So it could be -36.1. We put -36.1, right? So we keep doing the same thing for the rest, right? So I'm going to have, so we see that the limit of this function when s approaches 2 equals plus and minus infinity, which means it does not exist, right? Because you see that the limit of the function f when s approaches 2 minus, it could be somewhere right here. It's go to -infinity right here, right? And this guy somewhere right here, right? It's go to positive infinity, right? Now question 2. Find the limit of the function cosine of 1 over s when s approaches 0, right? So we just graph this one, right? So we're gonna press home screen right here, graph. Then hit enter. It's gonna be right here. And you see that the limit of this function when s approaches 0 is oscillating, right? So the limit of this function does not exist. Now let's move on to question 3. Limit of the function f of g of s when s approaches 2, right? So we're gonna let u be g of s, right? Then we need to calculate the limit of the function g of s when s approaches 2. So 2 is right here, the function g is right here, right? And you see that the function is discontinuous as equals 2, right? And this guy should be 4, right? But the graph is not above the line y equals 4. You see that? It cannot be above, right? So the limit of the function g of s when s approaches 2 equals 4 minus, right? Because you see that this guy right here is always below 4, right? So you need to use this one right here for the next one right here. So basically I substitute u for g of s over here, right? And then I have limit of f of u, right? And then g of s right now is u, right? And it's gonna be 4 minus, right? So u approaches 4 minus, right? Go back to the function right here. It's gonna be the same thing as limit of f of s when s approaches 4 minus. So we're gonna use this guy right here, right? So 4 is right here, right? And 4 minus, which means on the left of 4, right? So it's gonna be 2 right here, right? So the answer is 2. Now let's move on to question 4. Limit of f of s minus 1 times g of s when s approaches 1. Alright, so in order to determine if the limit of this function exists, we need to calculate the limit of f of s minus 1 times g of s when s approaches 1 plus, right? And the second one, limit of f of s minus 1 times g of s when s approaches 1 minus, right? If these two guys are the same, then the limit exists, right? Now, this guy right here is the product of two functions. I just separate these two guys, right? So, I have limit of f of s minus 1 when s approaches 1 plus, right? Now, since the input right here and right here different, I need to make them the same in order to use the function f right here, right? So in order to do that, I just look at this guy right here, right? I look at the input right here, it's going to be s minus 1, so I subtract 1 both sides, right? So it's going to be limit of the function f of s minus 1 when s minus 1 approaches 0 plus, right? Now, since this guy and this guy the same thing, right? So, I can use the graph of the function right here, right? So, it turns out to be limit of f of u when u approaches 0 plus, right? Now, I look at this one, 0 plus is right here, so it could be right here, right? So the function approaches positive infinity, right? Now the second one I need to do is I need to find the limit of this one, right? So I have limit of g of s when s approaches 1 plus. Look at the function g right here. When s approaches 1 plus, so it could be somewhere right here. The function approaches 3, right? Now we're going to multiply this guy and this guy. So the answer is positive infinity, right? Similarly, I have equals limit of the function f of s minus 1. Now I just subtract 1 both sides, right? So I have s minus 1 approaches 0 minus, right? Now this guy and this guy the same thing, so I can use the function f right here to find the limit, right? So it's going to be limit of f of u when u approaches 0 minus when u equals s minus 1, right? 0 minus it could be negative infinity right here, right? Now limit of the function g of s when s approaches 1 minus, right? 1 minus is still right here, so it's still 3, right? Now I'm going to multiply this guy and this guy. The answer is negative infinity, right? So this guy equals negative infinity. Now this guy and this guy are different, right? So the limit right here does not exist, right? Now let's move on to question 5. Limit of ls plus 1 over gls plus 3 when s approaches 1, right? So we just separate these two guys, right? So first I need to find the limit of the function f of s plus 1 when s approaches 1 plus, right? Now in order to use the graph right here, you need to make this guy and this guy the same, right? So I have limit of f of s plus 1. Now I'm going to add 1 both sides, right? So I have s plus 1 approaches 2 plus, right? So then I can use the graph of the function right here, right? Now it's going to be limit of the function f of u when u approaches 2 plus, when u equals s plus 1, right? Now 2 plus it could be 2 is right here, right? And 2 plus it could be 3 right here, right? So the answer is 3. Similarly, I have limit of the function g of s plus 3 when s approaches 1 plus, and then it's going to be limit of the function g of s plus 3 at 3 both sides, so it could be s plus 3 approaches 4 plus, right? So it could be limit of the function g of u when u approaches 4 plus, right? So we use the function g right here. 4 is right here, right? 4 plus, it could be this guy right here, right? It could be -2, right? Now, this guy is 3 over -2, which is -3.5, right? Now let's move on to question 6. No calculator. The piecewise function for the function f of s is below. Find the value a, b, c, d that makes f of s continuous everywhere. Alright, so we're gonna review the definition of continuity, right? So we go back over here. We need to make sure the function is continuous as s were 1, right? So we have limit of the function f of s when s approaches 1 minus equals limit of s squared plus s minus 2 over s minus 1, right? This is 1 minus right here, right? And this one is 1 plus, right? We're going to factor the numerator, right? So it could be limit when s approaches 1 minus of s plus 2 times s minus 1 over s minus 1, right? Now this guy cancel out. So it's going to be limit of s plus 2 when s approaches 1 minus, and then it's going to be 3, right? Leave it over there. Now limit of the function f of s when s approaches 1 plus, I'm going to use this one right here, right? So it's going to be limit of b times s minus c square when s approaches 1 plus. It's going to be b times 1 minus c altogether square. Leave this one over there, right? Now we have f of 1 is going to be right here equals a, right? We're gonna determine if the function is continuous as s were 4, right? So we do exactly the same thing, right? So we have limit of the function f of s when s approaches 4 minus, right? Now 4 minus, we still use this one, right? So we have limit of b times s minus c square when s approaches 4 minus, right? Substitute 4 for s, so it could be b times 4 minus c square, right? Similarly, limit of the function f of s when s approaches 4 plus is going to be limit of this one, right? So it could be 2s minus 8 when s approaches 4 plus, and substitute 4 for s, it could be 0, right? And then f of 4 equals d right here, right? Now, by definition of continuity, right, we need the limit of ls when s approaches a exists, which means the left must be equals the right? So we need to equate these two guys right here, right? So I have b times 4 minus c altogether square equals 0. This is the first one. The second one, this guy right here and this guy right here must be the same, right? So I have b times 1 minus c altogether square equals 3, right? Now I'm going to divide this one vertically. So what should I have? B and B cancel out, right? So I have 4 minus c altogether square over 1 minus c altogether square equals 0, right? So does that mean 4 minus c square equals 0, right? And then 4 equals C, right? Now C equals 4, I substitute back over here to solve for B, right? So have B times 1 minus 4 square equals 3, right? So B equals 3 over 9. It's going to be 1/3. Right? Now we know that limit of the function f of s when s approaches 1 equals f of 1 in order for the function to be continuous, right? Now f of 1 equals a, and limit of the function f when s approaches 1 equals 3 right here, right? So then a equals 3. Alright, so you have a, b, c. Now you need to find the same thing. You have the limit of the function f of s when s approaches 4 equals f of 4, right? F of 4 equals d right here. And the limit right here equals 0 right here. You see that? 0. So you have d equals 0. Right? And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand